Hello and welcome to our series of From Mind to Mind webinars. The topic for today is Scale Your Embedded Systems with Model View Presenter Architecture. My name is Tony Butler and I'm joined by not one but two of our embedded specialist engineers, Rafał, Jasiński and Bochyński. I hope you've pronounced your names correct. Guys, just to start us, could you just introduce yourselves to our audience?
Hello, I'm Arek, an embedded software engineer with nearly 7 years of experience. I've worked on a variety of embedded systems from hi-fi audio devices and marine applications to IoT systems, always focusing on clean code, clean architecture, and maintainability. Currently, I'm developing firmware for stationary engine controllers with the MVP architecture, and I'm glad that I can share the benefits of this approach with you.
Yeah, so hello, my name is Rafał Jasiński. I am a senior embedded software engineer for SoftwareMind, and I have been working on embedded devices throughout my entire career. I have worked in fields such as maritime industry, automotive, and a little bit of IoT. In the past, I have been involved throughout the entire life cycle of embedded product development, starting from concept work, ending with delivery, and then some maintenance. And I'm very happy to be a host, be a speaker on this webinar.
Thanks, guys. Well, we really do look forward to exploring more around this Model View Presenter and its benefits, and we'll get into that shortly. Just a little bit of housekeeping before we start. For our audience, if you've got any questions throughout this webinar, then please feel free to write them in the Ask a Question box that should be on your right-hand side of your screen. If you see a question that you were going to ask, but it's already been asked by someone else, then just vote for it, and that question your vote will keep it near the top. So we look forward to getting your questions, which we'll go through at the end of the webinar. So perhaps just to get us started, guys, could you tell us just in general, what is Model View Presenter?
So basically, Model View Presenter is one of the architectural design patterns. It has been used in various applications already, but it isn't really that popular in embedded devices. The main goal of it is to split the application into three components, three layers that are communicating between each other with a set of events or requests.
Thanks, guys. So it's interesting just that brief overview. So why would an organization actually want to use it?
Yeah, because having those well-defined components, it decreases time to market and heavily improves maintenance. It's much easier to add new features and fix bugs because at once you know which component should be updated and the rest isn't touched at all.
Great, thanks. That's interesting. I think we'll probably touch on some of those benefits later as well, which will be, I think, really interesting just to delve into those a little bit more. So obviously we've got this we're talking about today. Is there alternatives? If so, what are they?
Yeah, there are some alternatives and quite similar to the MVP, and they are like Model View Controller or Model View Model.
Yeah, one of the alternatives Arek has mentioned, Model View Controller, is pretty similar as they are sharing two components, Model View Presenter, Model View Controller. The only difference is controller and view and presenter. But for our use case, we figured that the presenter, although the name is really not suggesting much, is a better use case for our devices rather than Model View Controller.
Yeah, exactly. And also we have this MVVM, this Model View Model architecture. And basically, this is usually the go-to architecture for modern applications, but it has a bigger, heavier overhead, and it's more difficult to implement in restricted environments. So mainly because of data binding between view and view model. And it uses different descriptive language. So, yeah.
Yeah, and of course, MVP is not the end-all be-all solution to every problem that an embedded device faces. Every final choice should be, carefully considered during the conceptual phase. But as MVP is relatively unpopular in the field, we've decided to be the main point of today's webinar.
Yeah, and also it's worth to mention that those architecture and MVP architecture is rather used only when we have some kind of user interface, right? Because that's the point, to split different parts of the code base to different components. And of course, it's pointless to have presenter or view when we don't have any user interface, right?
Thanks. That's good overview of that. So I'm guessing that on our webinar today, we've probably got some people which have been working with embedded systems for some time, perhaps some are new to it. Could we just touch on what are some of the common challenges for creating firmware in embedded systems?
Yeah, mainly the memory and computation restrictions, right? It's an embedded environment, so it's quite restricted. We don't have so much memory and computation power. So that's the most common problem engineers face when developing code for embedded systems.
Yeah, but recently the restrictions are becoming less and less prevalent, to be honest. We are getting more powerful microcontrollers. We are getting basically single board computers even, which is basically unheard of like 10 to 15 years ago. So with the progress in mind, we can focus on code structure and architecture more and more.
Yeah, and also we need to say that some time ago it wouldn't be possible at all. Or maybe, it would be much harder. The overhead would be too high to implement some kind of architecture with old microcontrollers.
Well, okay. So obviously, I think from what you're saying that, some time ago, this would have been really difficult, a real challenge.
Yeah.
So I think it's really good that we're, timing is good. So, I mean, you mentioned before about there were some alternatives, but today we're really concentrating on MVP architecture. So could we just break that down a little bit and just share with our audience, what are the components of MVP architecture?
Yeah, so let's start with model. The goal of model is like to put there the whole business logic of the device, all of the communication protocols and other controlling the environment. So then the user interface is split from the model, from the business logic, right?
Yep, and the glue between basically other parts is the presenter. And inside of the presenter, we should be putting code associated with all the presentation logic, meaning if a device has an LED or a display or maybe a set of gauges, we should be putting all the logic in and how to operate them inside the presenter layer, as well as the user input that we are gathering for buttons, different rotary encoders, all that things should be the logic behind how to operate with these should be put inside presenter as well.
Yeah, and the third one, the last one, component is a view, which is about to gather all of the inputs from user. It has all of the buttons or touch display or other rotary encoders, and it displays the state of the model, all of the potential gauges and meters, all of the data basically, right, to the user.
And as of right now, the names are purely theoretical, and maybe somewhat unclear the difference between the presenter and view maybe. But in a moment, we're going to prove that the model view presenter actually flows very nicely in real life, on a real life scenario.
Great. Well, I think we'll all look forward to seeing that. So perhaps I'm going to sort of change tack a little bit. So if I'm in a business and we need, we've got embedded devices, etc., and we're developing for that, this, from what I'm hearing, is a quite a different way of working of old. So if I'm trying to sell this to my business, say, look, we need to change how we do this, how we manage, our embedded systems. What are some of the main, I guess, selling points, want a bit of an expression, of MVP architecture in embedded devices? What would I say to those that really need to convince that this is the way to go?
Yeah, some of the benefits of MVP can be used as selling points, as you mentioned. So basically, clearer separation of responsibilities of each part of the application. We are splitting them up so that we can have more direct control over them. And especially, we are separating concerns and aspects of the application so that it's not just a monolith where one change can affect others, but we are making these parts and components very clearly defined. And another benefit that MVP comes with is that with a modular approach, let's put it this way, we can have finer control over resources of these components. So we can have a benefit of optimization as well.
Yeah, also additionally, it means that it's easier to communicate through the members of the team or even different departments, because we know that the change needs to be made in the specific component. So it's easier to communicate, right? Because we are more specific where the change needs to be made. Yeah.
It's really interesting. Thanks, guys. So if we all live in a competitive market, our clients compete with their competitors. So how would this MVP architecture potentially reduce your time to market and help these organizations to actually have that competitive edge?
Yeah, one of the benefits of using something like MVP and architecture is that it has been battle tested elsewhere. It has been proven to work. And during the conceptual phase, during the design of the entire firmware for an application, for a device, we don't really have to basically reinvent the wheel and come up with the same conclusions all the time, as we can use something that's already present.
Yep, and also a known design pattern can establish common nomenclature for each component of the application, so it's easier to communicate. Like also I mentioned already, with other team members, and like describing problems and creating issues, it's much easier and better. And also the thing is that if we touch one component, the others aren't touched at all, right? So it's decreased the time to market because of that fact, because we don't break other components, right? We don't need to debug them, what happened, what's wrong, what has changed.
Wow. That in itself would just, save a huge amount of time and potential aggravation, wouldn't it? So, it's interesting that you mentioned, Rafał, about this is a tried and tested thing. So we're not talking about something that is so new that no one's ever done it. And I think that's really important to get across to everyone, is that this, particularly if they're trying to sell this within the organization as a new sort of way of doing it, this isn't brand new. There is tried and tested ones out there which have used this model, which is really key to know. So just on that then, is there some examples of using MVP in projects that you can share with us?
Yeah, we'd love to share an actual case study for a product that we have helped develop. So just a brief introduction on the product that we see here. A customer has approached us to ask us for help in firmware development as the product became more advanced, and there became more variants of the product. The development basically ground to a halt. Every bug fix generated more. Every change was very risky, as the monolithic application basically had tightly coupled parts and aspects of each of these products, and the development basically stopped after some point. So we were queried to help with this. And one of the answers for us was the MVP for this very product.
Yeah, also it's worth to mention that previously each product variant had its own code base. So if they want to fix some bugs or something like that, they needed to do it at every code base again and again. And also that those code bases differed a bit, right? So it required some kind of a bit reverse engineering, right? You needed to understand again the code and apply the bug fix for every product variant separately. Yeah, so the maintenance was quite awful, even, I would say. So with MVP, we can see we can share that code base through all of the product variants. So, like, for example, like already we mentioned, we have that model which has the business logic only, so we can share that code base through all of the products. So, for example, bug fixes are propagated at once to all of the product variants, right? And yeah, also we can see like we have a presenter here. We have buttons and display, and we can split everything to separate code bases. But let's focus on the model first. So, like for this device, what we have, let's say it's a mock-up because we can't share too much information about our current project, but it's kind of similar. And let's say in the model we have communication protocols implemented, the whole business logic, sensors handling data, everything like that, which, like I mentioned already, it might be shared to all of the product variants.
Yeah, and as we did mention, the model it's there. So, for instance, as Arkadiusz mentioned, the communication protocols. But when we look at the current implementation of the current use case, we can very clearly see that what comes as a view, right? The buttons, the LCD, LEDs are already there. They are part of the view and the way we operate with them. So how do we display text on the LCD, right? Or how do we inform the application that a button has been pressed? Or maybe we need to have support for button holds or double presses. This is kind of this is supposed to be put in a view component, but based on the state of the machine, maybe the escape button does nothing when we are in the very first page of the LCD. This logic about how a button operates is meant to be put in the presentation layer. So if we are in some sort of a menu system, the way that we operate it with arrows should be the logic behind them. It should be put in the presentation component. So this kind of use case shows that it's relatively simple to talk about a product in a matter of model view presenter. And additionally, just to prove the point even further, we'd love to go through a little new feature added to this product. So one of the new design aspects would be to add a new communication protocol, right?
Yeah, for example, like Modbus, right? Let's say that the hardware supports already the Modbus communication, and just with the firmware update, we can add to all of the product variants. We can add the Modbus feature, and only the changes need to be done in the model. And just like that, we have with update, we have firmware update, we have Modbus support, right?
Yeah.
Yeah, and another thing maybe Rafał, we can say about adding touchscreen LCD, right?
Yes, it would be another variant of the product. So for instance, we want to have a new product with a touchscreen LCD rather than buttons at all. So in order to accommodate for it, we have the model, we can reuse it again for the variant, right? So the code is reusable. But adding the touchscreen LCD would require us to provide a new presentation layer and view. The view would know how to operate the touchscreen and all the panels on it, you know, how to react to different touch presses on it, or maybe like drag and drops, all that jazz. And while the presentation layer should support this view. Maybe even some of the parts of the presentation could be reusable as well.
Yeah, so once again, the model it's not touch at all. So it means like bringing a new product variant is relatively quick, right? Only the presentation layer and the view needs to be written, and you know the model is tested, everything works properly, should work properly, and the product is ready to be released.
Well, I just want to go back and touch on a couple of things that you said, just to really clarify, because if we think about sort of the traditional way that perhaps, you know, clients have done this in the past. So if I had, I mean, this I know it's a mock-up of one that we've done, but if that was, you know, me and I had 10 of these various devices or different variants of them, and I wanted to, and an end client said, can we now have them as touchscreen? Mm-hmm. Back in the traditional way of doing it, I mean, that would be a huge amount of work, wouldn't it? Of doing every single device or the code base for those devices.
Yeah, exactly. Like the whole code base would be needed to be rewritten, right? To adjust to new hardware. Exactly. Everything would need to be right again and tested again, you know, with different hardware. So it would require a lot of time, right?
Yeah.
To be honest, the touchscreen would be a variant of a product, to be honest. Maybe if we wanted to add Ethernet support for every product, this would cause a waterfall effect on every code base that we have, because we need to have a fairly complex communication protocol put in every one of these. So
yeah,
this would be even more difficult to actually implement in the legacy approach.
Yeah, I mean, just from a time perspective, I mean, I'm guessing we're talking of potential months of time. We're not talking of hours. It's almost into perhaps months of saving in time, isn't it?
Yeah, I would say so.
Actually, yeah. Which is, you know, when we talk about our competitive market, we talk about, you know, getting to market before someone else. I mean, that's a massive advantage, huge advantage.
Yeah. Basically, with some very new and flashy communications, then this can save quite a bit of time, especially when we are sharing the implementation between each of the products.
Yeah. And just on from that, then, if we think about maintenance, and we know, you know, from just experience, that often there is a huge amount of work put into and focus on the upfront development, but then when it comes to maintenance, and it might be handed over to a maintenance team or however that is structured, keeping something going, keeping it relevant, keeping it up to date, you know, that again can sometimes be even more work than the actual upfront development in the first place. From what it sounds like, this has a huge impact on the ongoing maintenance as well.
Yeah, very much. And another benefit is that one that Arek did mention, that with common knowledge, with common tongue between the R&D and the product department can somewhat guide the R&D, the development team, into figuring out where a problem may lie, right? So that they might say something along the lines of, all right, the communication seems to be a little bit buggy here. So, all right, we as developers, we currently think like, all right, it's communication. So we should probably start looking in the model, or maybe it's just that the way that the presentation layer is, has a problem, has a fault, and we are just not displaying it right. This might be another issue, but as soon as we have the same way of talking to one another, it's much easier, much faster for us to do maintenance as well.
Yeah, it's like in the issue, it might be described that exactly the issue is in the model, for example, right? Not in somewhere in the code base, and the goal is to find it first. Like making some reverse engineering and looking for this wrong code. Now you limit your search only to one component, so it's much easier and faster to find the broken code.
Yeah, that's a real difference. I'm going to ask a question now, which I hopefully won't throw you. I'm going to go off piece a little bit. So we've spoken about that this is a very different way of doing things to perhaps how development's been done in the past and traditionally. Perhaps one of the things that our audience may be wondering, that if they do sell this as a new concept into their business, what does training look like? I mean, is it really difficult? How long would it take someone to get up to speed on using MVP?
It kind of depends on the product. With more advanced ones, of course, but it's going to take longer, right? Pretty obvious. But it's not the matter of just how complex a product is, how complex the application is. If we have a very complex environment, if we have a very difficult task to fulfill, having code just stand in the way of you trying to get to know the device is even more challenging. Okay. And with an architecture like MVP, we are splitting it up. We are making sure that logical parts are bundled together in clumps, in components, in layers, and at least this part is easier for us. Okay. If I were to judge on how much faster it would be, it's really product dependent. I don't really want to throw out a number that I cannot fully, support.
Yeah. But no, that's fine. I mean, it's I wasn't sort of expecting it to be a hard number, but it was just if it was a different way of working, from what I'm sort of hearing from you is that it's once you get your head around sort of a new concept of the actual platform as such, then actually the benefits of putting in that work of learning a new way of doing things, far outweighs the time benefit. So
yeah, very much.
Yeah. It's that's really interesting. So that's been really, really helpful, guys. I think, just giving us, I mean, I know we could probably sit and talk here for hours around it, but I think hopefully it's given enough of an overview to our audience. We do have a question that's come through. I've just seen it pop up from Carl South. And his question is, what are some aspects you can consider when deciding whether you should use MVP in a project? I suppose what Carl's asking, I think, is, does it suit every project? Or, what are the things that would make us decide whether we should use it or shouldn't?
Yeah, of course, the first thing is, like already we mentioned, that the project, let's say, needs to have a user interface, right? Then the MVP pattern might be used. And also it would be very beneficial to have it when we have a lot of product variants. Like we share the functionality through different products. Then we have this shared code base, right? And we change only this presentation and view layer that needs to be changed and updated. So those two are the main beneficial things.
Okay. Yeah, and with a design pattern such as that, if we want to maintain the product for us for a longer period of time, having an architecture to follow would mean that we can actually reduce the cost of maintenance as well, right? So it's because it's easier, it's faster, it's well defined from the very start. So that, sorry.
Yeah, exactly. The thing is also that when the project is quite complex and it's going to be the maintenance is going to be for a long time. So it means that we are going to have a lot of lines of code. So it's much easier to follow the code when we have it split to 3 components, right? Because like looking for broken code or just where should I change the code and going through like thousands of lines, it's like might be horrible, right? And at least we know that, okay, the change should be made in the presenter, for example, right? It's much easier to find the place where should be something changed.
Yeah, exactly.
Yeah, interesting. So I guess for the reasons for using it could be different to various organizations. If an organization is being pressed to really control costs, perhaps even reduce costs around, or go to market quicker, then all of these things would be, I guess, reasons of why you would want to look at somewhere like MVP. So yeah, different reasons.
Yeah.
We've got another question up here from Jerry K. Thanks for your question, Jerry. It says, what are some potential challenges my team might face when implementing this pattern?
To be honest, it depends on the way that the actual implementation is already done in place, right? It might be a case of just rearranging the current software components, or it might be a case of rewriting major parts of it. Probably the biggest factor would be how the application already manages dependencies. And I mean dependencies like libraries, but I mean dependencies to the hardware architecture that we have. If it's relatively separated, then going for the MVP can be a quicker and easier process.
Okay.
Yeah.
So we're going to say something, Eric?
Maybe also because it depends on the team, right? We are going, let's say, because we are applying some kind of architecture, so the team members rather should be a bit, at least some experienced, right? It's because there might be more kind of interfaces needed to be done between the components. It's just more advanced a bit, right? Yeah, that might impact the time of improving, of adding the architecture.
Sure. Okay. So I mean, it's going to vary from team to team, isn't it? So
yeah,
I guess the first thing is deciding that this is a new way that we're going to sort of embrace to get our embedded systems sort of out the door, and the way that we're going to support them.
Yeah, but it's not like a commitment that's basically from this point on, we are going MVP, and everything else that we've done has to be thrown out. It's a choice that can be applied gradually as well.
Okay. That's interesting, and I think quite key for our audience that it's not a complete, lift and shift of everything. So that if it's a gradual, that's key as well, I think, because I think that would probably be quite scary for an organization to go, oh my goodness, we've been doing this for years. now, we've suddenly got to change everything. So I think that gradual sort of migration as such is key.
Of course, it depends on the application, right? As everything, but we can, for instance, have this way started in one variant and then propagate it further in case of different product variants, or maybe if it's not really much of the way of a product variant dependent, we can just have a part of the application move to the MVP, move to the architectural approach, and then gradually start refactoring what is already there in a way that is going to pay off in maintenance cost.
Sure.
Yeah.
Okay. That's been really interesting. Thanks, guys. It's we really appreciate you sharing your knowledge and experience on what I think will continue to grow and be a key topic for many organisations. So I guess it's fair to say that we've seen MVP can make a huge difference in not just the development, but also in the support of embedded systems, which is something that I think everyone's probably looking for. So, and we thank everyone for our questions that you've asked as well. So I think that just about brings an end to our webinar today. If there is a section of the webinar that you've missed, or you want to watch it again, then it has been recorded, so it will be available for you soon. So we do appreciate that. We just want to say a huge thanks to Rafał and Arik for your insights in this topic of MVP and the benefits. And that's been really, really interesting. If you do have any questions to our audience, if you do have any questions or things specific to your organization, if you require assistance on your embedded strategy or implementation, then please just feel free to get in contact with either Rafał or Arik using our email, or feel free to connect with us on LinkedIn as well. So we want to say thank you to our team behind the scenes for running the webinar for us. And but most of all, we really want to say thank you to our audience for joining us here today. We do hope that this webinar has been insightful, and we look forward to seeing you again on our next From Mind to Mind webinars. Thanks, everybody.
Yes, thank you.